Question 9. R and S are points on a circle and O is the center as shown in this diagram. We are then asked to shade a segment. Shade a segment of a circle. Now, the segment of a circle is a part of a circle that is either side of a chord, and a chord is a straight line that connects any 2 points on the circle like this. So there are two answers to this. We have this in here as being a segment, one side of that chord, or technically you could shade everything that is in this, and that would be the other side of the chord. Then that would technically class as the major segment, and this in here would be the minor segment, but either of those would get you the marks. Part B, I already mentioned it, but write down the mathematical name given to RS. A straight line that connects any 2 points on the edge of a circle is known as a chord. You can think of this in terms of a guitar. With strings, you've got chords, and even just kind of seeing it, these straight lines going through a circle like that. That's how I remember it. Anyway, next, in the diagram below, P and Q are points on a circle, and O is the center. We've been given an angle of 18 degrees in here, and the end game here is to find the size of angle PQT, which is this. So, 18 degrees is where we start. We use angle rules in order to figure out the other ones. The fact that O to P is a radius and O to Q is a radius tells us that 18 degrees will not only be here, but will also be here because of the fact that we have an isosceles triangle. So I can write here angle OQP equals 18 because base angles in an isosceles triangle are equal. Anytime you use knowledge of an isosceles triangle, this is the money line right there. You need to refer to base angles. If you have your isosceles triangle, normally you look at it this way. The base angles refer to the angles on the bottom, on the base, left and right, when you have the equal sides, left and right. So if you turn your head to kind of look at the triangle that we have this way, nope, don't know why that's gone, this way, then these two would form your base for that. So base angles in an isosceles triangle are equal, is the end of that statement. After that, we then use knowledge of the fact that a radius meets a tangent at 90 degrees. So the fact that that's 90 degrees means that if we take 18 away from 90, we will get our answer. So first of all, a radius meets a tangent should clarify that it states here that QT is a tangent to the circle, and a tangent to a circle is basically a straight line that touches the edge of a circle. So radius meets a tangent at 90 degrees, which allows us to say that for angle, well, our answer basically, our angle PQT is going to equal 90 minus the 18 that we had from before. Don't know why I want to keep this color coded, but here we go. And that's going to give us 72 degrees. That's it. Done.